Welcome to this video on the Sieve of Eratosthenes. In this video I'll show a way to solve it using Python. So we go into the page here, and there's a separate video where I explain what we should do. In this one I will jump into, basically the idea is to find the next number. Like we can see here in the first example, we are sent the list 0, 2, 3, 4, 5. And we should do find next prime. So in this case we should skip the zeros and we go to the first non-zero, which is the 2. So we return the 2. So find next prime is going from the left to the right in the list that we get, called sieve, and we return the first non-zero integer that we find. So that's the first one we're going to do. So let's do the coding here in find next prime. Okay, so this would be the code. We're using a function in Python called next. So next will find the next value from an iterator like this. So an iterator is like it's almost like a list, but it's not realized in memory. So we haven't actually written it to memory, so to say. It's more of a function that yields the next number in a certain series. And here we use a shorthand in Python. We will say I. So that's what we get in each step. It becomes a little bit complicated here. For I in sieve. So the sieve is the input list with the integers from, which looks something like the example that we had here, 0, 2, 3, 4, 5. That's the sieve. For I in sieve means we go through it from left to right, one by one. I is what we return, but we only return it if I is not 0. So if it differs from 0. So this is the iterator, or we can also think of it as a kind of a list. Then there's also default value here, which might not come into play, but if there is no I found in the iterator, so no I which differs from 0, then we'll return -1. So let's try to run that and see what we get. Yeah, so we did return the first 2, but since we haven't done cross off prime yet, we don't get further than that. So we did find next prime correctly, but cross off prime is not correct yet. So if we look at what the task was there, it looks like this. So we should take a list, the sieve, which is still a list of integers, the same concept like before. But we also get a prime sent into the cross-off prime method, which is the task is to cross off all the numbers in it, which is a multiple of 2. So in this case, if we get this input list at the top, we should cross off the 2 and make that into a 0. The next one is 4, we make that into a 0, and all the multiples after that also from 1 to 100, we should turn into 0 and return this new list at the bottom here. So if we go to the code window, we can realize that here. So start writing the code here. Okay, so there we have the code. I decided to do a copy of the input sieve in this return sieve. That could be skipped as well, but that's the way I did it now. Just because it feels good. Then we go through with the for loop. So we go through the range, and then the range has 3 values here. Let's call it A, B, C. So A is the start value. So that will be the prime. So in the case where we cross off numbers here, we will get the prime 2. So that means that in the code here we get 2 as the first value. 1 is the end value plus 1. So this will go all the way to 100 at most. And then prime again in this first example would be set to 2. So this is the step that it would take. So this range here would give us, remember it was a start, end, and step. So it would give us first 2, then we step with 2, so we get 4, then we get 6, 8, 10, and so forth. And that gets put in number. And then what we do in the sieve that we're about to return, we take the number. So the first time it will be 2. We deduct 1 because if we look again at the list we have here, we see that number 1 is this slot here that has index 0. 2 is the second number that is on index 1. 3 is the third number, it is in index 2. So the index in the list is always 1 lower than the number here. So that's why in the code we take number -1 to get the index in the list, which is return sieve. But then we just set that to 0. And after that, going through all the numbers up to 100, we return that return sieve. So now if we run the code, hopefully, here we'll see we found prime number 2, and then we cross off all those numbers. Then we found 3, we cross off all the multiples of 3. Now we find 5, cross off all the multiples of 5. Then we find 7, cross off all the multiples of 7. And now as you see there, it's less and less numbers that might be prime. And it also goes, I guess, quicker and quicker here to cross them off, although it has mostly to do with the animation. But so the numbers with circles here are the ones that we are returning as primes. Like so, 37. Then we have a prime twin here, 41 and 43. And as you see, it's less and less work to cross off the multiples because now we're past the midpoint. So yeah, there are no more multiples to cross off basically than the number itself. And here we have it. So it's 5 times 5. It's 25 primes from 2 to 100. So that's how you can solve the Sieve of Eratosthenes in Python. Thank you very much for watching.